Welcome to this session. My name is Obaro Ogbo. I'm a senior software engineer with Microsoft, working out of Lagos, Nigeria. For this session, I'm going to be discussing the updates to the file server test suite. And then I'll hand over to my colleague Adedeji, who will discuss the work we've done with parsers for Wireshark. So for the file server test suite, I'm going to give an overview of test suites and the file server test suite specifically. Talk about what's new in this version, and then discuss the ways that you can give us feedback or contact us. So what is a Windows Protocol Test Suite? The Windows Protocol Test Suite is a collection of test suites, and each of the test suites in this collection evaluates the implementation of a family of protocols. For File Server Test Suite, which we are focused on in this session, it evaluates the implementation of protocols that have to do with file sharing. For example, SMB2, FSA, and so on. We also have RDP Server Test Suite that tests remote desktop protocol server implementations, RDP clients, Active Directory, and so on. Now, the test suite helps evaluate whether a protocol implementation meets interoperability requirements. What this means is it compares the expected behavior by the protocol implementation with how the protocol is described in the protocol documents. The test suites were originally developed for in-house testing of Microsoft's Windows behavior to test and verify that the behavior mirrors exactly what is documented in the open specifications. And it's now also being used to test third-party implementations. So each of the test suites do not cover every protocol requirement in the protocol documentation. And passing all the test cases in a test suite does not certify. I mean, the test suite is not a certification. If you pass all the test suites, you are not going to get a certification, but it's a useful indication of interoperability, meaning, you pass all the tests the way your implementation behaves as described, and you'll be able to interoperate with every other implementation that is correctly implemented. The Windows Protocol Test Suite's architecture. Currently, the Windows Protocol Test Suites are cross-platform. They run on Windows, Mac OS, Linux, and any other operating system that .NET 8 can run on. So the test suites are built on .NET 8, and since .NET 8 is cross-platform compatible, the test suites are cross-platform compatible. The test suites are built on Protocol Test Framework and the Proto SDK, and each of the test suites is built on its own implementation, built on the same foundations. At the top of that, we have PTM Service and PTM CLI. PTM stands for Protocol Test Manager, and they provide interfaces to run each of the test suites. PTM Service is a browser-based interface, while PTM CLI is command-based, and is useful for integrating with your pipelines. This is a cross-section of the available test suites. They are currently open source on GitHub. The URL is on the screen, github.com/Microsoft Windows Protocol Test Suites and Protocol Test Framework. For file sharing, we have the File Server Test Suite that tests the protocols on that row, SMB2, FSRVP, SWN, and so on. We have SMBD, which is SMB over RDMA. We have branch cache, also under file sharing. For security, we have Kerberos, AZOD. And at the bottom of the screen, we have XCA, which is the Express Compression Algorithm. We have a test suite for that. Moving into File Server Test Suite, which is the focus of this talk. This is the scope. These are the protocols that are covered. We have SMB2, Server Message Block Protocol version 2 and 3, It doesn't support version 1. Version 1 has been deprecated. I'm sure we all know that. MSFSA, file system algorithms, Hyper-V remote storage profile, all these protocols that have to do with file sharing are supported under this file server test suite scope. And the messages that are supported, or the protocol features that are supported, this is some of them, not exhaustive. Negotiate messages, session setup, IO control codes, query directory, file leasing, these are all supported. The dialects that are supported are dialects version 2.002 all the way to dialect 3.11. So the approach we have for writing test cases, we have two approaches, traditional tests and model-based tests. Model-based tests are tests that were generated using a test case generator, which is no longer supported. So the existing tests that were generated are still supported. They are still in the test suite, and you can run tests against them. Run those tests against your implementation. If there are any errors, we still support those test cases, and we can work with you to figure out what is going wrong if it's failing, but we no longer expand those test cases. All the current tests we write now are traditional tests, in the sense that we manually review the protocol documents, look at the test scenarios, and then write a test for that particular functionality and scenario. So all the new test cases we are writing for now are traditional test cases, which we write by hand. So the basic infrastructure, if you want to run the file server test suite, you should have the test suite installed on a driver computer. The test suite is going to act as a client. So it's a synthetic client, which is going to connect with your file server, which is going to be the SUT. Your system is going to be under test, your implementation. The test suite connects with your SUT either using TCP or using Quick. Quick has been supported for the past couple of versions. And the protocol test framework is built on MS Test. So if you've worked with MS Test before, working with the protocol test framework is going to be a breeze because it's just a layer on MS Test. And it provides configuration, adapter logging, and network capture across all the test suites. The protocol adapter is an implementation of the protocol test framework, and through it, using the protocol SDK, we write test cases that connect to the system under test. In some instances, you might want the SUT to be in a particular configuration before a test is run. In those instances, we have something called the SUT control adapter. So it basically helps control the SUT and set up, in case you need some files to be set up before the test is run, or you need the system to be in a particular state, you can use the SUT control adapters to ensure that your system is in that state before the test is run. And if you need to, revert the system state after the test, you can also use the control adapter. The general environment, we have two environments that the test suites can run on, or that the test suite can test. The first is a basic or a standard environment where we have the driver computer. In this instance, below the horizontal line, we have client 01. So that is the driver, and node 01, which is the SUT. The two machines can be on a domain, but they do not necessarily need to be in a domain. All you really need is the driver computer and the SUT. Then we also support, the file server test suite also supports testing a cluster environment. In the cluster environment, you can think of everything below the top horizontal line as the SUT. So the scale out FS, general FS, node 1, and the storage, they are all in a cluster. They form a cluster, and that is the SUT, while the client is the driver computer. So we support testing, file server standard testing, and file server cluster testing. Going into what's new for the current release. The current release is available on github.com as at today, version 4.24.4. the file server test suite has been updated to .NET 8. We added a couple of new tests and fixed some bugs from previous tests. The protocol test manager service, PTM service, has also been updated. At the last release, we included the feature to enable custom test categories. So basically, you can set test cases to categories that make sense to you or to your implementation. Prior to that, we forced the categories that you could run test cases under, but now you can customize that. And the protocol test framework has also been updated to .NET 8. A walkthrough of one of the new test cases we wrote. We wrote this test based on feedback that we got from GitHub. Someone filed an issue, and we worked with them to add this test case for FSCTL create or get object ID. So this tests the algorithm for FSCTL create or get object ID on a supported file system. Detailed description is available on MSFSA and MSFSCC. So basically what this does is it verifies that if this control code is called on an object, if it's invoked on an object in a file system, we verify that the object ID is created or is gotten if it has an existing object ID. So the steps for this, we have the test or the driver computer and the SUT. The driver establishes a connection with the SUT, creates a file on the SUT, and then sends the control code, create or get object ID. We receive a response from the SUT, and we verify that the response contains a valid object ID object, which is a GUID. If it's valid, the test is passed. If it's invalid or one of the error codes, then the test is failed. So to contact us, you can contact us via GitHub. You can open an issue. If you have a feature request, you can open an issue. If you have a bug, if you've spotted a bug or you have any issues at all, feel free to open an issue on GitHub. If you have ideas for test cases, we are accepting pull requests. So, you can expand one of the existing tests or, write a new test case. Feel free to create a pull request. We'll be happy to work with you to get that merged. And for contributing, there's a contributing.md markdown file in the test suite repository. You can consult that and you find more details. If you have questions and you want to give us feedback, you can also email us at testsuitehelp@microsoft.com or open an issue on GitHub. If you have any feedback for us, open an issue on GitHub. We'll be happy to, have that conversation with you there or have the conversation with you via email. That's either one is fine with us. Thank you. I'm going to hand over now to my colleague, Adedeji. Hi, Deji.
Can you hear me?
Yes, we can hear you now.
Okay. All right. Hello, everyone. I'm Adedeji Adeloye. I'm software engineer on Protocol Test Suite team. Today, next slide, please. Thank you. We would look into what this session is not about, so we can manage our expectations as we go on. Why we have chosen Wireshark as our go-to protocol testing tool, our goal and contribution so far, and at the end, I have a demo and a couple of open questions. Okay, so this is not an introduction to Wireshark talk. There are enough resources on the internet that handle all of that, right? This is also not how to use Wireshark or comparing Wireshark with other tools. What we are going to be focusing on is what we are hoping to contribute to Wireshark. This is also not going to talk about how the protocols work. There is also a Q&A after now for those interested in topics like that. Okay. Okay, so why Wireshark, right? I think Obaro mentioned our interoperability commitment. And before now, as many of us know, we've been doing that with MMA, which is Microsoft Message Analyzer, right? However, that's been deprecated for a while now, and our new focus has now been Wireshark, based on feedbacks, recommendations, what is mostly common out there, and feedback from developers as well as partners, right? So we did a gap analysis, and we are then moving into Wireshark as to update Wireshark to make it up to date with the Windows protocol documents, and ensure that whenever you use Wireshark, you can have a correct view of your protocols on the wire. Okay. What we hope to achieve is to contribute dissectors to Wireshark to enable partners, customers, and all users of Wireshark get detailed and up-to-date information for Windows protocols. And you can see, next slide, please, in our contributions so far, we've made a few contributions to the SMB2 dissector. That's the packet SMB2 file that holds the dissector for both SMB2 and SMB3. The first on the list is the tree connect response flags. Isolated transport flag was added to the protocol document, and this was being ignored in Wireshark. That's available in Wireshark as of today. Query info also adds some flags: SL restart scan, SL return single entry, SL index specified. Those flags were previously not being dissected, right? And they have been added as of today. FSCTL set integrity information X is an ioctl control code. I have a demo on this, as well as FSCTL REFS stream snapshot management. Both of these are covered in the demo. Next slide, please. Also, we've added server to client notification. This is a recent message that was added to the SMB protocol. It allows the server to send a notification to the client to perform an implementation specific detail, right, without expecting a response back from the client. Also, further contributions include file full EA information, lock response, and code bugs that we discovered while working in the SMB dissector code file. Okay, we'll move into the demo now, and yeah. I'll be demonstrating two of our dissection updates to Wireshark SMB2 dissector. The first demo is FSCTL set integrity information X. This is a FSA control code only supported on REFS systems. It is used to request the server set integrity information on a file or directory. I have two versions of Wireshark running on this client. The first is the current official version 4.2.3, and the other is the updated Wireshark version that has dissection updates. You can get a copy of Wireshark with this update from Wireshark portal. I have a link to that at the end of my slides. Looking at the highlighted packet 104, we can see that official Wireshark version doesn't understand the data, so it leaves the data as unknown in its raw binary format. On the flip side, we can see what it looks like after we are now dissecting the control code, the full dissection data. Second demo is also on another control code, FSCTL REFS stream snapshot management. This control code is used to request the server perform specific snapshot operation on a given file data stream. The request is captured on packet number 25. Again, because it is not being dissected on Wireshark current official version, it is displayed as unknown with the raw bytes. However, we can see what the full request payload looks like now that it is being dissected. We will continue to update Wireshark with more dissections as we go on. However, if you work regularly with these parts we have updated, We want you to try it out, and we are happy to get your feedback. I'll be, dem I'll be demonstrating two of our. Okay. Yes. So, by the way, I think there's a new Wireshark update that has been released after that video was done. Okay, and here I have some open discussions, right? We want to get a feel of how you do SMB3 decryption on Wireshark on Windows. Just so that we can also gather more feedback and see hopefully if there's a way we can make this experience better, right? So I don't know if you have any takers. That's SMB3 with encryption over TCP, not quick. I know this is one area whereby we've seen people trying to use MME4, but then would like to get a feel of how regular Wireshark users are getting this done on decrypting the message. And also, what other contributions would you like to see next, right? So that we can take this back as to-dos and go work on them. Okay. Feel free to try out the some of these features haven't been released yet. You can get them from Wireshark Daily Builds on this URL on the slides, and also feel free to send us feedbacks on wiresharkhelp@microsoft.com, feedback, contribution, issues, or any other places you think you'd like us to pay attention to, and we'll gladly look at that. Thank you.